Hi, geometry students. Welcome back to Chapter 10. We're moving on to Section 10.2, Measuring Angles and Arcs. So in Section 10.1, we talked about all the bits and pieces of circles. So you know diameters, you know radius, you know how to find circumference and area. So now we start talking more about circles. This chapter is all about circles. So in the little fine print there, it says we're going to recognize major and minor arcs, semicircles, central angles, and how to find measures and arc length. So first of all, let's talk about a central angle. You know an angle already, right? The word central is giving you a huge clue. It is an angle with a vertex in the center of the circle, which means if I talk about this angle 2 right here, the sides of angle 2 are both radiuses or radii of that circle. So angle 2 is a central angle. It is made up of two radiuses. So it's an angle with the center of the circle as its vertex. So the sum of central angles, we can deal with this just like we dealt with all angles. The sum of all central angles equals 360 because we know that there's 360 degrees in a circle. So if I looked at these three angles, angle 2 that I already marked, angle 1 that has these two radii as its sides, and angle 3, I could say that angle 1 plus angle 2 plus angle 3 equals 360 degrees. If we had smaller parts, we could say it equals something else, but we know that the sum of all the angles, or the sum of all the degrees in a circle is 360 degrees. Keep that in the back of your mind. It comes in handy. Kind of like the triangle sum theorem, all those other things that just keep popping up. So those are angles, right? Angle 2 is a central angle. And then we talk about arcs. So an arc is the actual part of a circle defined by two endpoints. So on this second circle here, I've got this arc. It goes from R to P. And if I actually just pick that piece of the circle out, I take out that curved segment, I've got myself an arc. So arc PR or arc RP. So we write it as PR, and we put a little tiny arc above it. Or remember, it doesn't matter which order we name it, just like a line or a segment or anything else, we could call it RP with the arc symbol above it as well. Now PR is formed by this central angle. So if I wanted to talk about a central angle, Q is the center of the circle. So the radius QR and the radius QP form an angle. This would be the central angle. And arc PR that ends with those two radiuses is the arc itself. So the angle is inside the circle. The arc is the actual part of the circle. So keep an eye out for those two things. They're very different, and we're going to treat them differently, and we're going to talk about them differently. So let's talk about arcs first. So we've got minor arcs, major arcs, and semicircles. You're going to find this very easy. So let's start with a minor arc. A minor arc means that, let's see how I've got this, it is less than 180 degrees. So when I look at this first example here in this box, I have got myself arc AB, and it is the central angle is marked with an X. So this central angle is marked with X degrees, but remember the arc is the actual part of the circle. So when we name a minor arc, we're going to name it with two endpoints. I'll put the, two endpoints with the big old arc symbol above it. So in this example, we would have ourselves an arc AB. It's a minor arc. It's less than 180 degrees. And the arc degree is equal to the central angle. So whatever the central angle is, that's what the measure of the arc is as well. So I could say in this particular example that the measure, I'll do a small m, of arc AB is equal to the measure, remember that small m means measure of, it is equal to the measure of angle ACB. So the arc is the same as the central angle. Easy peasy. If you know one, you know the other. Major arc is greater than 180. So it's more than half the circle, right? So notice in this example, my endpoints are A and B, but I'm going the long way around the outside of the circle. So when we name this major arc, we have to use 3 points with our arc symbol above it. And I need to say that the endpoints go on the end, and the point in the center, the third point in the middle, tells you which direction. So in this one, I would name it arc ADB. Or I could name it the other way around, BDA. BDA. So it doesn't matter in which order, as long as your endpoints are the end and the direction. So if I don't have a third point in there, that means it's a minor arc. I always go the short way unless it tells me to take the long way around the circle. Start at A, go through D, and stop at B. So that would be my major arc. It's greater than 180 degrees, right? So I see I've got that little X degree in here. So this X degree is not the central angle. This whole thing would be the measure of that arc. So what I'm going to say is for my arc degree, I'm going to say it's equal to 360 minus the central angle. 360 degrees minus the central angle. In this case, that central angle is X. So let's say that I said that this central angle right here was 60 degrees. Well, that's definitely not the major arc, right? That's too small. It's got to be greater than 180. So I would do 360 minus 60, and I'd say, okay, to get from A all the way around through D and back to the end point B, that would be 300 degrees, because 360 minus 60. Last but not least, we've got ourselves a semicircle. This is the easiest one of all of them. It's equal to 180 degrees. So it's half a circle. Here's the thing. When I've got this marked on this particular diagram, notice A and B are my two endpoints, and it's going through D. Well, I always take the shortest route, but if it's a semicircle exactly halfway, I don't know which way around the circle I want to take. So this one we have to name with 3 points as well. So you automatically know that 2 points is a minor arc. Everything else is 180 or higher. So this one I could name ADB. Or if I wanted to go the other way around, BDA. And easy peasy, we know that the measure of a semicircle is equal to 180 degrees, halfway around the circle. I also want to add one little thing. That means if I look at my diagram that AB, segment AB, is a diameter. Diameter cuts a circle in half. It goes right through the center. It's the longest possible segment through the center. So AB is a diameter. All right, so let's do an example where we name major, minors, and semicircles. So in circle R, remember we name our circle with the center, so I know that R is the center of the circle. Identify each arc, type, and measure. I do know enough to know that. I should have put in the directions that PM is a diameter. Add that. Segment PM is a diameter. So what if I asked you about, let's start with the easy one, arc PQ. What would you tell me, first of all, what's the measure of arc PQ? Is it major or minor arc? Well, since it only has two letters, it's a minor arc, right? So arc PQ is a minor, and it is equal to P to Q. If I trace these guys in to my central angle, the measure of the central angle is the same as the measure of the arc, so 115 degrees. What if I asked you about arc, let's do NP. Well, first of all, I'm giving it away. It's only two letters, right? From N to P. It is less than 180 degrees, so this one's also a minor arc. So we've got ourselves N to P. If I trace those in, my central angle is here. I'm hoping everybody sees 90 degrees for that one. What about arc PQM? PQM. So from P, let me take my writing off here. From P to M, those are my two endpoints, but I have to go through Q. So the measure of that one and what kind of arc it is. Well, since I told you this, PM is a diameter, right? So that means that PM cuts the circle in half. That means that this has to be a semicircle. So I'll just say semi, which means how many degrees is it? 180 degrees. How about one more? Let's do, how about arc NP? No. How about, let me switch that. How about arc NQP? Arc NQP. So arc NPQ, we know it's either a semicircle or a major arc, right? Is it greater than 180 or larger than 180? Definitely larger, so it's a major arc. So if I traced this in, here's my two radiuses. This is my central angle. Well, this is kind of like that last one. If I know that this angle right here is 90 degrees and I know that the sum of all the angles in a circle are equal to 360, how many degrees do I have for that major arc? It's got to be 270 degrees. Let me ask you one more just because I want to make sure we do a little bit of math on this. How about arc QM? What's the measure of arc QM? So from Q to M, so it's a minor arc, right? Smaller than 180 degrees. I only gave you two letters. If I trace that in, if I know that central angle, I can know the angle of that arc QM. Well, we actually do because we said a couple problems ago that from P to M was 180 degrees. And I know that this part of it from P to Q is 115 degrees. So what do I have left for that X right there? Feel like the semicircle minus the 115 is going to get us our arc QM, or our central angle, angle QRM. Remember, the arc is the same as the central angle, so what's that going to be, like 65 degrees? So there's a couple sneaky problems. You might have to do some adding and subtracting. You need to know if there's diameters in there. All right, so let's talk about congruent arcs theorem. In the same circle or in congruent circles, two arcs are congruent. This means if and only if, you know how math people are, we like symbols and to abbreviate things. Two arcs are congruent if and only if their corresponding central angles are congruent. So in other words, If we've got congruent arcs, then we've got congruent central angles. Or I can switch it around. That's what if and only if means. If I got congruent central angles, then I have congruent arcs. So if I've got angle 1 here, let me just mark this. Let's say that angle 1 is congruent to angle 2. What does that mean for arc FG and arc JH? So if these two angles are congruent, I'm going to do some highlighting. So if I highlight this out so I can see my central angle, so my central angle and my arc are congruent, right? So angle 1 is the same measure as arc FG. Angle 2 and arc JH are the same measure. So if angle 1 and angle 2 are congruent, that means that arc FG is also congruent to arc JH. Or I could go the other way around. If I knew that those two arcs were congruent, then I could say that angle 1 and angle 2 are congruent. So I can flip-flop this. So if you know the arcs, then you can say the angles are congruent. If you know the angles, then you can say the arcs are congruent. Let's talk about adjacent arcs. We know the word adjacent. We've been talking about this all year. Adjacent means next to each other, right? So arcs in a circle that have one point in common. So if I look at this diagram right here, I've got an arc XY and I've got an arc YZ. Those guys share the endpoint Y. They are next to each other. So we could say arc XY is adjacent to arc YZ. The reason that we need to know that is because the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. It's a lot of words, right? Let's do this. Let's kind of take a look at this. Notice how in this diagram, they did not draw in the radii. We didn't draw those in. We're just looking at the arcs. But what we're really saying is arc XY is formed by this angle. And we know that that angle with its vertex at W is the same as arc XY. And we know that WY, WZ, this angle right here, I'll put 2 marks there, this angle is the same as arc YZ. So you can picture those radiuses be in there. So what this is saying, this is just like the angle addition postulate that we talked about way back in the day. Add up the two parts, you get the whole. So if I added up arc XY plus arc YZ, that will give me arc XZ. It will give me this whole thing from here to here. So if I add up this piece plus this piece, I get the whole thing. Whether you draw the radiuses on there or not, we still get the whole thing. So add up the two angles, you get the whole thing. Add up the two arcs, you get the whole arc. So now we need to make sure we've got a distinction between arc measure and arc length. Measure is in degrees, right? So measure, let's put degrees. Arc length is an actual length, like say inches, feet, centimeters, whatever that might be. So if I ask you about arc measure, you need to think, how can I say this in degrees? If I ask you about arc length, I've got to think about feet, inches, miles, whatever it might be. So arc length is the distance between the endpoints. If I took that little segment right out of my circle, that curved arc, and I measured it, that's how long it is. In order to figure out arc length, we have to set up a proportion. We have to say that arc degree, so our measure of our central angle over 360, equals arc length over circumference. Or if you prefer, we could say arc degree over 360. It's usually x equals arc over 2 pi r, right, circumference, or pi d, if you like pi d better. So we're going to set up a proportion, and we are going to cross multiply to solve it. Arc measure is actual degrees. So remember, the measure of an arc is the same as the central angle. So in this example down here, I've got arc YZ. Well, the measure, the degrees of arc YZ is the same as the central angle. So arc YZ is equal to 75 degrees. This value right here would go into the top of that first ratio. So we'd have 75 over 360 equals something over 2 pi r. So in this example, it says find the length of arc ZY or YZ, however you want to name it, right? We've got a choice. So let's set up ourselves a proportion. So the arc degree, we said the measure of the arc was 75. This is always 360 down here. It says to find the length of the arc. So that's going to be our x. That's usually where our x goes. Over the circumference. Well, we could do this on the side, or we could just put this problem in. So I'm going to say, well, the radius is equal to 4 inches. So I'm going to say 2 times pi times 4. From there, I can go ahead and cross multiply to solve this. I'm going to do all my paper and pencil math first because I know I've got a pi in there. It's going to be irrational. So I'm going to end up with a 360x equals 75 times 2 times 4, which is going to be, oh gosh, what is that going to be, like 150, 600 pi. And then I'm going to divide both sides by 360. So I'm going to go to my calculator, and I'm going to do, should put an approximately there, right? 600 times pi, divide by 360. I'm going to get approximately 5.24. So this is 4 inches, the radius. This is 4 inches as well, because radiuses are all congruent. This is 5.24 inches. So it's just slightly longer than the radius if I picked that out and straightened it up and measured it. So watch when it's asking for arc length or arc measure. All right, so now we got some good algebra problems. Refer to circle T. So T is the center. RV is a diameter. That's really helpful, right? If this is a diameter, I know that that's a semicircle. It's cutting the circle into 2 congruent parts. Find the measure of angle RTS. Find the measure of angle RTS. So RTS is this guy right here. That's doable. Find the measure of angle QTR is the other one. So let's start with this. Well, let me just say this. I could have also said find for number A, find the measure of arc RS. Started making an angle there. Arc RS. That would be the same question, right? Because RS is the arc to the central angle RTS. Well, this one's a really sneaky one. There's a couple ways you could do this, but before I can do anything, I've got to think about how I can find x. Well, I'm going to use that diameter to my advantage. Once I know x, I can find everything I need to know. If RV is a diameter, RV, and I go this way around the circle, diameter is a semicircle, 180 degrees. So this is that adjacent angle postulate as well. Couldn't I say when I add up those 3 parts, they have to equal 180? Angles are either equal to each other or they add up to something. So I could say, I'll do it over here, 8x minus 4 plus 13x minus 3 plus 5x plus 5 has to equal 180. What I'm actually doing is I'm saying this angle plus this angle plus this angle all makes up a half a circle. That's what I'm doing. I'm ignoring the 20x for now because I don't need that. That's not a part of that. I could have also used some vertical angles. I'm not sure if anybody noticed vertical angles in there, but I'm not 100% sure that QU, I don't know if that's a radius, so I'm going to avoid that. So let's do some quick math here. Let's see, 8 plus 13, I'm going to combine my like terms here. 21, 26x minus 4 minus 3 is minus 7 plus 2 equals 180. So I'm going to subtract 2 and get 26x equals 178. And I believe that gives me a 7. Is it a 7? Oh, this is a minus 2. Fix this. Sorry, guys. So if I add 2, I get 182. Now that will give me a 7. There we go. So x is equal to 7. Once I know x, can I figure out the measure of arc RS or the measure of angle RTS, the central angle? Sure, I'm just going to plug that 7 in there, do the math. 7 times 8 is 56, minus 4 is 52. So this guy has to be 52. And then I could go from there and do some more math. So it feels like those angle problems that we did before. All right, let's talk about one last thing. I'm going to skip this example. Let's jump up to number 4. Find the measure of each central angle of the category. List them from least to greatest. So it tells me that mountain bikes bought last year is 37%, but that's not the measure of the central angle, right? Mountain bikes. So we just have to do a quick little math problem. So if I'm looking for this arc, or if you prefer, this central angle, it's 37% of the circle. How many degrees are in a circle? 360. So I'm going to do 360 degrees times 37%, which we know turns into 0.37. When I do that math problem, that gives me the degrees. So if we want to turn a percent into degrees, make yourself a note. Percent to degrees, you're going to do 360 times the percent. Make sure you turn it into a decimal before you multiply. Otherwise, your math won't make sense. When you add up all of those things, when you figure out the number of degrees for comfort, for others, for hybrid, for youth, they should all add up to 360. If they don't add up to 360, it's because of rounding. So you know it's going to be like 359.97 because of rounding, something like that. But it should be really close to 360. All right, there's a lot of different things. Central angles and arcs are the big things. Watch out for those. Come in with any questions you've got and have a fabulous day.